My solve for X is making solar energy cheaper than fossil fuels with no subsidies. So that's a very tall order. I believe it'll be revolutionary and important for the world. And I'll explain to you how I think we can get there. First, I want to frame the problem, and then I'll tell you the moonshot thinking that I think we need to apply to succeed at this. So first, when you look at the different forms of energy that we get today, hydropower is the cheapest, but all the good lakes and rivers have been dammed up and have been used. We can make hydropower for about 3 cents a kilowatt hour. Next, we have coal, just about 5 cents now. Natural gas is coming down close to that price, but still higher. Then wind, and then solar, which is up near 20 cents, just barely getting below 20 cents. So all the solar that's been deployed in the world that has been connected to the grid has been subsidized by some kind of government or some other form of incentive. In the United States right now, we have a 30% investment tax credit that drives down the price of the 20 cents closer to 14. That's still higher than the 12 cents we pay for retail electricity in California. So what you have to do when you want to build a power plant and put that electricity in the grid is you have to get a permit to increase the cost of everybody's electricity from 12 cents to 12.1 cents. And of course, people don't like that. If you could actually make the power for less than the price of fossil fuels, this would take off at a scale beyond our imagination. So what do we have to do to get there? Well, first, PV panels have been coming down in price dramatically over the last few years, but the total installed system price has not been coming down fast enough. So there's a lot of other things that are complicating the price of the systems that's not allowing us to get down the cost per watt or the cost per kilowatt hour low enough, fast enough. Next, if you compare the two major methods of converting sunlight to electricity, photovoltaic on the left and concentrated solar power on the right, photovoltaic panels cost about $224 a square meter to make. And the mirrors, the high reflectivity mirrors, low iron glass mirrors that are used in concentrating solar power plants are only $18 a square meter. The reason why this ends up being so expensive, though, is there's so many other costs behind that $18 a square meter that add up to make them even more expensive than photovoltaic. This is one example of a plant that does that, and its breakthrough thinking is going to be needed to get the price another factor of 3 lower so you can compete with fossil fuels with no subsidies. And I wanted to give you some sense of why it's so difficult. In the past, 20 years ago, 30 years ago, people made these huge heliostat tower mirrors. And a number of companies recently, BrightSource, eSolar, and others, have broken up those large mirrors into smaller mirrors and put more computer control and less mass. And that has lowered the price, but still not nearly enough. The cost per square meter of installing these systems is still in the $100 to $200 per square meter range. Even though the mirror itself only costs $18, by the time you do everything else to track it and mount it and install it, you end up costing well over $100 a square meter. You have to have rows of racks of steel to hold them all in place. You need that kind of structure. You need a gearbox to hold it and actuate it. You need to actuate it accurate to about 1/10 of a degree. And one of the very expensive parts, believe it or not, is this final gear. The final gear in the gearbox has to hold all the torque load of the wind. Because if one tooth breaks off that gear, your system is shot. So you have to build for the 100 mile per hour outlier wind case. And no matter what you do, whatever size mirror you make, even as you make it smaller, this ends up being quite expensive to control and track those mirrors. And then you need to support the mirrors. You need some kind of metal to hold them in shape. Whether they're curved or flat, you still need to support them like that. And you need to make frames behind them. And then you need to build the whole power block. The whole power plant needs a power block and cooling towers and all the other stuff that goes along with it. And all of this requires lots of construction and crews. And all of those things end up blowing your price. And I alone, just from some companies that I started, have invested over $200 million in the last 10 years trying to drive the price down. I think people in the room here have invested more than $1 billion trying to do it. And around the world, many billions of dollars have been tried to get the price down to fossil fuels, and we're just not there. So if we're not there with that, how are we going to get there? Well, first let me tell you about how long I've had this passion. When I was 14 years old, I grew up in the San Fernando Valley. It was the year 1973 when the energy crisis struck. And there were odd and even number days. You had to buy gasoline, $5 rationing of gasoline in California. And I just started reading Popular Science and any magazine I could about what was happening in the world of energy and what could be done. And I started sketching little Stirling engines and other things I could do to convert sunlight to electricity. And I made my first Stirling engine in metal shop in high school. And then I started making little parabolic dishes for them. And I even started selling plans for them. I went down to, made a little booklet called The Parabola and how to concentrate solar energy with a parabola. And I copied these at Kinko's, and I sold these plans for $4 in the back of Popular Science magazine. I ended up selling 10,000 copies of these plans, which helped me pay my way through Caltech. In fact, I think I might even got accepted to Caltech because I was doing this at the time. So this had a huge influence on me when I was young, and that's why I was so passionate about it, but still not able to get down near the price of fossil fuels. So I think we need a moonshot for cost reduction. We need some really radical out-of-the-box thinking to get the price down. And for the last year, I was trying to think of what areas we need to apply that type of moonshot thinking, and I've outlined these areas. We need to rethink storage. And I say this because when you're making a solar plant, and it's only going to run for 6 hours a day, you can't afford the capex of that thing sitting idle for the other 18 hours. And that's been a real killer in getting the price down. So if we can come up with cheap enough storage so the plant can run around the clock, that would be an important breakthrough to get the price down. We need to rethink the engine. After building these power plants with big power blocks from GE and from Siemens and all the construction costs to do that, we need to come up with something that's much more modular, much more install it and forget it, that can run for 20 years with no maintenance, something that requires no water. We have to be able to put these things where there is no water, so we really need to rethink how we do the energy conversion. We need to rethink the actuation. If we're going to move something, we need to rethink how we can move it dramatically cheaper. And then finally, we need to rethink the installation. We can't have these construction crews out there in fields. If we want to build gigawatts and terawatts of power, we can't do it with these one-off construction and engineering projects. You're never going to get the price low enough because the capex of a solar plant is 95% of the cost of its operation over 20 years. The capex of a fossil fuel plant is only about 5 or 10%. The cost over the many years is the fuel, so you're amortizing that over a long period of time. Here, the capex is all up front, so you have to come up with some way to make that much, much cheaper. So let me give you some examples of moonshot thinking that I think we need to make, hopefully as instigation for other things that people can take away and brainstorming that we can take to try and really make this happen. So first, on the storage. The first idea that we've come up with, but there are many others, is to come up with a form of storage which is integrated rock storage right in the tower. So what we do is we put rocks in the tower. Rocks are as cheap as you can get. They're $20 a ton. They're basically as cheap as dirt because they are dirt. And you fill the tower with rocks. You heat the rocks during the day, and the power plant will run for the 18 hours at night. You can recover the heat. You can have insulation around it, so you only lose 1% per day. And this will allow you to produce power on cloudy days, and even a week later with only 7% loss. So I think rock storage is one example of a very, very cost-effective way to all of a sudden get a 24-hour plant. Second, this new modular engine, a Stirling engine as an example, that can be put at the base of each tower and just produces electricity. That way you don't have to pump anything around the field. You don't have to pump hot fluids. You don't have to pump oil, molten salt, anything. You just pump electrons. You have to make solar more like a wind farm, where at the base of each tower, there's a wire that comes off with electricity, and not where you have to pump expensive or hot things around a field to bring them to a centralized turbine. Next, and this might be the biggest breakthrough, we need more thinking around this area, and it's this. The realization that when you're trying to concentrate sunlight, you're really just bending photons, weightless photons, and yet you're building this strong structure, and I explained to you the heavy-duty gear you need to make to be able to resist the 100-mile-an-hour wind. Well, one idea we came up with in the last year to try and break through away from that is to make a retractable pool cover solar field. What you do is, as soon as the wind is above 25 miles an hour, you just cover the field. And all of a sudden, everything you put below the cover can now be very lightweight. You don't need nearly as much metal. The actuation can be very delicate and wire drive. You can actually actuate the mirrors almost like a marionette with very delicate stainless steel cables. All these things can dramatically reduce the cost of the field because now you're no longer fighting the elements, you're just hiding from the elements. And in wind power, wind is your friend. In solar power, wind is your enemy. And most of the cost of the solar field is going to resisting the wind. And that can be simply avoided by just hiding or covering the field.
But why don't you just keep it covered all the time with clear cover?
You could use a clear cover. That would be a possibility. You would lose 8% of the light going through the cover and 8% coming back through, and that might be a possibility as well. But the basic idea of not fighting the wind and making something very delicate just to bend the photons, I think it's a huge new movement, and I think something like that is what's going to be needed to get the price where you need to go. And then finally, this is what that actuation could look like. You could have a very delicate beam. The mirrors can be pulled very simply. You can have centralized motors that actuate them. And now you need very, very tiny motors and drives, not those big heavy-duty gears I showed you. And then finally, and a nod to Rodney, who's right here, you need robotic field installation. You have to get away from cranes and construction projects. And what I'm envisioning here is a factory in the back of a U-Haul truck with 2 of Rodney's robots right in the back. And what's inside here is an aluminum roll and a roll forming machine, stacks of mirrors, a bunch of actuators, and as the truck is driving at a mile per hour, the field is being rolled out from behind the truck. Now, if you could build a PV factory in a truck, you might be able to do a PV factory like this as well. But a PV factory has all the clean room aspects and all the machinery, and also a PV factory costs $1 billion for a gigawatt. This thing costs $50,000 for a gigawatt. It's way, way cheaper. $50,000 for the 2 robots, $50,000 for the truck, and you can be basically building way, way higher volume for way lower capex. And just from some simple calculations of this, with this truck moving a mile an hour, going 10 hours a day, even if you're only working during the daylight hours and you don't have to work only during the daylight hours. Right now, we have installed a total amount of 100 gigawatts of solar in history. You would be able to do 100 gigawatts a month with a number of trucks in parallel rolling out something like this. So there actually is the potential, since all there is aluminum and glass, and then the rock storage and the engines, to be able to roll out a lot of this with a relatively low capex. And then where does all this lead? So some combination of all these things leads to, you start off with the old system of lifting up these big things on cranes and mounting them on the ground. The mirrors are $18 a square meter. That's flat. You're using the same mirror in both cases. But here you need the crane, here you don't need a crane. Here you need the backing, all the metal. Here you make the mirror small enough that you don't even need a backing. And of course, as you said, if the mirror's underneath glass, the mirror doesn't need any steel in the back of it anymore. So you save all of that cost. The actuation goes from $45 a square meter down to $9. The metal frame that goes in the ground goes from 27 down to 8. The labor goes from 24 down to 7. And you're down from $150 a square meter, basically, to 47. And at 47, you can finally get to that price. What all this leads to is a plant that could look like this. You have to make the field 4 times bigger than you used to have to make it if you want to run 24 hours a day. Because for 6 hours, you'll gather enough energy to run for 6 hours. Now you need 3 more fields to make enough power during the day to store it to run for the 18 hours when the sun's not out. But if the field is cheap enough, you can afford to do that. Where all this leads, when you add it all up, is with these kinds of moonshot thinking and many more, I hope this will inspire more conversations while we're here, you can actually get to 4.9 cents a kilowatt hour. 4.9 cents a kilowatt hour with no subsidy whatsoever. And I still think there would be subsidies. There might be some price of carbon. There might be some other government help. But here you can actually produce solar power and put it in the grid and lower people's energy bills, not have to go to the public or the commission and try and get them to get approval to raise people's energy bills. Once you can lower people's energy bills with solar, I think it'll take off like crazy. And I'm really, really anxious about making something like this happen in the world. But after a decade of frustration of trying to do it, I feel the only way to get there is to win on price. We're not going to win by winning people's hearts. We're only going to win by beating the price. And I think moonshot thinking is going to be required to get there. Thank you very much for listening to a great audience.